So good afternoon everyone. So today we shall discuss the second laboratory experiment. So this is related to the order database. So another set of tables are given. For the given table we will create them, insert the value, and then we have to run the queries. So in this particular database only three tables are given. Salesman. This table has attributes salesman ID, name, city, and commission. Second table is customer table, customer ID, customer name, city, grade, and salesman ID. Orders table include order number, purchase amount, then order date, customer ID, and salesman ID. So in general, this particular database includes the information about the salesman, the customer. So it is based on these attributes, so we can say that each customer is served by a salesman. So that's why a salesman ID is included in the customer. So this salesman will serve the customer. Then in the order, we'll have order number, the amount, date, purchased by the customer, and the salesman who sold the product or who placed the order. So three tables we need to create. Then we shall look at the queries. So by having a look at these queries, so we'll get to know what values we have to insert. So first one, count the customers with grades above Bangalore's average. So which means in a city column, we are supposed to have Bangalore. Find the name and numbers of all salesmen who had more than one customer. So it says when we insert the data, at least one salesman should be such that he has more than one customers. So list all the salesmen and indicate those who have and don't have customers in their cities. Use union operator. So here for salesmen, if you observe here in the salesman table also we have a column city, and in the customer table also we have a attribute city. So this city belongs to customer, which means the city in which the customer is residing, whereas this city indicates it is for salesman, the city in which the salesman is residing. So two cities are there. So based on whether a salesman is having a customer in his city, so a customer can be from Bangalore and salesman can also be from Bangalore, then it indicates that that particular salesman is having a customer in his own city, that is Bangalore. So that is also possible. And a salesman can have a customer from different city also. So if customer is from Shumaga and Bangalore is the salesman's city, then that is different. So that case is also possible. The next one, create a view that finds the salesman who has customer with highest order of the day. So view we have to create. So this concept we have studied in today's class, or in previous lab experiment also we created one view. So finding the salesman who has a customer with highest order of the day. So which means it is the amount, it is related to purchase amount. So for each day we have to find which is the highest purchase amount. For that order, who is the salesman? So that we need to display. Demonstrate the delete operation by removing a salesman with the ID 1000. All his orders must also be deleted. So in order to demonstrate this fifth query, so we need to have a salesman with the ID 1000, and we have to put on delete cascade for orders, so that the orders, all his orders are deleted. So with this, we shall look into the ER diagram. So this ER diagram is having three entities: salesman, customer, orders, and the attributes also we have mentioned. Salesman ID is the primary key for salesman table, salesman name, city, and his commission. Salesman sells the product to customer, so we can establish a relationship sell to customer. In the customer table, customer ID is the primary key. Other attributes include customer name, city, and grade. And another entity we have is orders. For orders, the foreign key is salesman ID, which comes from salesman's table, and customer ID will come from customer table. So these two relationship, we can give a name: takes, salesman takes the orders, or um, received from which customer. So that relationship can be established. And in the order table, order number is the primary key, then purchase amount and order date are the other attributes. So only three relations. So now let us look at the schema diagram. So three tables is written: salesman ID. So in salesman table, we don't have a foreign key. It is not referring to any other table. In customer table, customer ID is primary key. Then salesman ID is the foreign key, which is referring to the salesman table. In orders table, order number is the primary key. Customer ID is the foreign key referring to customer ID of customer table. Then salesman ID is referring to salesman ID of salesman table. So that is indicated using the arrow marks. So based on this schema diagram, we can now create a table and define the primary key and foreign keys also. So let us look at the table creation statements. Create table salesman. Salesman ID, we are declaring it as a integer and it is a primary key. Name varchar of 20, city varchar of 20, commission again we are declaring it as a varchar of 20. So these are the four attributes in salesman table. So after executing or creating this particular table, so we can describe this using the command DESC. DESC followed by salesman. So this is the screenshot of the result. So you can observe the table name, columns, data type, and length. So primary key is also indicated over here. Then second table, customer table. So create table, customer ID, it is the integer primary key. Customer name varchar of 20, city varchar of 20, grade integer. So we have declared grade also as integer. Then last attribute, salesman ID. This is the foreign key. So instead of declaring it using a data type and then referring it as a foreign key, so we can directly refer this. So that is salesman ID references salesman of salesman ID on delete set null. So if a salesman is deleted, then the particular attribute in customer table will be set to null. So that's why we are not deleting a customer if a salesman is deleted. So we are just setting that particular attribute value to null. So on delete set null. So you can observe the description of this customer table. So the command is DESC customer. So the various attributes, their data types. So primary key, it is indicated using 1. The last table, orders table. Order number, data type integer, primary key. Purchase amount, number 10,2. So this data type we have declared it as a number because we want the purchase amount to be floating also. Again, it depends on the application developer. So if we have 10.5 or 100.25, so if decimals are there, then we have to indicate how many digits will be there totally, and then how many digits will be there after the dot. So that we have to indicate it as a scale and precision values. So you can observe here. So number 10,2. So which means the precision is 10 and the scale is 2, which means after dot there will be 2 digits. Then order date, the data type is date. Customer ID references customer of customer ID on delete cascade. So if a customer is deleted, then order will also be deleted. Salesman ID references salesman of salesman ID on delete cascade. So it indicates if a salesman is deleted in the salesman's table, then this particular tuple will also be deleted. So those two foreign keys are indicated, and on delete cascade is added, so that if customer is deleted or salesman is deleted, then the order entry will also be deleted. So this is with regarding to the creation of tables. So once tables are created, we need to insert the values. So first we shall insert the values into the salesman's table. So insert into salesman values. So salesman ID, it is the first attribute 1000, followed by the name, city, commission. So we are inserting 5 salesmen with I starting with 1000, 2000, 3000. So we have to particularly add 1000 because in our one of the query it is asked to delete a salesman with ID 1000. So that's why, and the various salesmen are John, Ravi, Kumar, Smith, and Harsha. The cities we have included is Bangalore 2 times, Mysore, Shumaga, and Tumkur, and various commission entries are there. So once the insertion is done, if we execute all the 5 commands, we can check the values using select star from salesman. So this is a screenshot after execution. So we'll get this. And then similarly, we can insert into customer table. So insert into customer values. So first one is the customer ID. So there is no restriction on customer ID. So we can enter any values, followed by the customer name, city of the customer. So customers belong to Bangalore, Mysore, Chennai, and Bangalore. Then followed by the grade. Grade is an integer value. So there is no specification about the grade. So we shall insert any integer value. Salesman ID. And salesman ID we need to choose from these 5 only. Since salesman ID is a foreign key, we have to select any one value from these 5. If we enter any other value apart from those 5, our insertion command will not execute and it will throw us an error message. So this is the customer table, select star from customer. So if we execute that particular command, so this result we will obtain. Then finally the orders table. So insert into orders values followed by the order ID, purchase amount, date of purchase. So the syntax for entering the date is within the single quote. We need to specify the date followed by the month. Month we have to enter 3 characters of alphabets only. So it doesn't take the integer value. So it has to be in this format only. 3 characters followed by the year, then customer ID and salesman ID. So the customer ID and the salesman ID, we have to select from this one only. These values, whatever we have entered over here. So 5 customers we have entered, and on this particular day, 20th February, there are 2 orders. So once we enter the data into these 3 tables, so next we shall see the queries that are being asked. So first one, count the customers with grades above Bangalore's average. So first thing is we need to find what is the Bangalore's average grade. In the customer table, we have to find what is the Bangalore's average. Then we have to check how many customers have a grade that is greater than the average value of Bangalore. So there are 2 parts. So in order to accomplish this, so we need only one table, that is customer. So just look at the attributes present in the customer table: customer ID, customer name, city, grade, salesman ID. So the question is asked as we need to count the customers who have a grade greater than Bangalore's average. So what is Bangalore's average? We need to find. So Bangalore's average is here 100, here 200, and here it is 400. So 100 plus 200, 300, 300 plus 400, it is 700. So total is 700. Then its average will be 700 divided by 3. So it is around 233. So then we have to select the number of customers having a grade greater than 233. So that is 233 means, so 300 Mangalore, then Chennai, and the last Bangalore. So three customers will get. So three customers grade is greater than Bangalore's average. So that is with regard to our example. So in the query, see again, it is a nested query. In the inner query, first we have to select the average grade of the Bangalore. So that is select average of grade from customers alias is C2, where C2.city is equal to Bangalore. So this particular query will give the average of Bangalore city. Now in the outer query, what we are doing, select count of customer ID from customer C1 where C1 dot grade is greater than this particular value. So since this is a inner query, the first query will get executed first and the average value, that is 233 in our case, will be replaced within this parenthesis. Now it will check grade greater than 233 and the count we will get as a result. So here you can check the result in the screenshot, that is 3. So which means 3 customers are having a grade which is greater than the grade average of Bangalore city. So that is the result. So this is an inner query, but there is no correlation between the outer and the inner queries. So next, let us look at the second one. Find the names and numbers of all salesmen who had more than one customer. So we need the information about the salesmen who have more than one customer. More than one means 2, 2, 3, 4, and so on. So for that, what we will do is first we have to join the customer and the salesman table. So the join condition would be salesman ID, because salesman ID is the attribute that is common in both salesman and customer. So select salesman ID name from salesman alias is S, customer alias is C. So where S dot salesman ID is equal to C dot salesman ID. Now we are joining these two tables. Then we will group by salesman ID comma name. Once the join operation is performed, we will now have to divide it based on the salesman ID. Once we divide based on the salesman ID, then we have to check how many rows are there if it is greater than 1. So in order to do that, so we'll apply group by salesman ID and name. So both we are taking. So because whenever we use group by statements, whatever attribute list we have specified here, that only those will appear in the select statement along with aggregate functions if there are any. If we write only salesman ID here, then I cannot write name in the select clause. Since we need both the salesman number and the name, 2 attributes are required. So in the group by, we need to mention those 2. So now based on group by, now the joined result will be grouped based on a same salesman. Then we have to apply the condition on a group as a whole. So when we want to apply a condition on a group, we have to use the having clause. So then having count of star greater than 1. Now whatever condition which we have written in the having clause will be applied on a group as a whole. So count of star always returns the number of tuples or the number of rows. So it checks the number of rows in each group. If it is greater than 1, then that particular group is selected. So if the having condition is not met, then the entire group will be rejected. So in our case, we need more than one customer, which means the count of stars should be greater than 1. So now, if we run this particular query for the entered data, we will get salesman ID name. So two salesmen will be there who are having more than one customer. That is John and Ravi. Their ID is 1000 and 2000. So this we can cross verify with our customer table. So you can observe. So 1000 is present 2 times and 2000 is also present 2 times. So in the customer table. So next, third one, list all the salesmen and indicate those who have and don't have customers in their cities. Use the union operation. So as it is being given that we need union operation, so we can divide this question into two parts. So first part is the salesmen who have the customer in their own cities. And second part is those salesmen who don't have the customers in their own cities. Then we will club these two using the union operator. Here, what is being said is we need an indication. So that indication will tell whether they have or don't have. So in the first part, so we shall consider those salesmen who have the customers in their own cities. So the query would be select salesman ID, salesman name, and along with this we have an indication, that is have. So if you observe here, this is not an attribute. Instead, the character or a string we have directly specified over here within a single quote. So that is have as indication. The name, the column will be renamed as indication and its value will be have. So in SQL, so we can directly specify values for certain columns by specifying them in the select clause itself. So which means whatever tuples that are returned by this particular query will have the string have as a column. So the query is, so joining salesman and customer. So we have given alias S1 and C1. So S1 dot city, that is the salesman city, is equal to customer city. So this condition will tell us, or the matches the cities of the salesmen. And the join condition is salesman ID of S1 and the salesman ID of C1 should be same. So it is based on the salesman ID. We are joining the salesman and the customer table. So once we join it, then we will check whether the salesman city and the customer city is same. So two conditions will be there. So now this selects all the salesmen who have a customer in their own cities. It returns the attribute salesman ID name. Along with that, another third column will be there that will have a value have. Union, the second part. So the second part is retrieving those salesmen who don't have a customer in their own cities. So when we have a condition, this is a negative condition like this, don't have, we will be having a nested queries. So what we do is, so we have to join the salesman and customer, but for each salesman, what we do is we'll check whether he has any customer in his city or not. So that is the first condition, and we will then negate it. So look at this query. Select salesman ID, name, don't have. So the string which we are using here is don't have as indication. From salesman S2 is the alias, where S2.city not in. So we are selecting this particular correlated nested query. His city should not be in this particular list. Select C3.city from customer, where S2.salesman ID is equal to C3.salesman ID. So whenever we have a correlated nested query like this, for each salesman, this inner query gets executed. So if we have 10 salesmen, then this inner query will be executed for all those 10 salesmen. Suppose, see why we have written a condition like this. A salesman can have 5 customers. Out of the 5, one can be, at least one can be in his city and 4 can be in other cities. If such situation is there, it comes under the first case, that is he is having a customer in his own city. So which means in the second part, we need only those who don't have any customers. So what we will do is, for a single salesman, we will try to extract the cities of all his customers. So that will be present in this inner query. So this inner query, what it is doing is, it is joining a salesman tuple with the customer tuple. Then it will extract the city. If we run this particular, when this inner query gets run, it will give the cities of all the customers of a particular salesman that will be listed over here. Then we will check not in. So his city should not be in this list. If city is present inside, then that particular salesman is not selected. Only those who don't have will be selected. So when we run this entire query as a whole, the entire thing, and these two parts is combined using the union operator. So this entire thing is a single query. So when we run this, our output will be like this: 1000 John have, 2000 Ravi have, 3000 Kumar don't have, 4000 Smith don't have, 5000 Harsha don't have. So this is the result. So have indicates John and Ravi are having a customer in their own cities, whereas Kumar, Smith and Harsha don't have the customers in their own cities. So let us try to understand this. John and Ravi, first let us take 1000 and 2000. So let us go back to the data and verify. So 1000 John is from Bangalore, 2000 Ravi is from Bangalore. Now in the customer table, just verify 1000. So 1000 means John. So John is having a customer in Bangalore and Mangalore. So but John's city is Bangalore. So it indicates John is having a customer in his city, that is Bangalore. Then similarly Ravi 2000. So 2000, it is appearing here, these two. So he is having a customers in Chennai and Bangalore. Then out of this, Ravi's city is Bangalore, which means he has a customer in Bangalore. Now Ravi and John will be in a indication have. Then Kumar, let us say it is 3000. So here it is 3000, 3000 is in Bangalore, which means he has a customer in Bangalore. But Kumar's city is Mysore and he has only one customer. So Kumar city is Mysore. His customer is from Bangalore. So he don't have a customer in Mysore. So Kumar will be in not have. And the remaining two salesmen, that is Smith and Harsha, They are from Shumaga and Tumkur, but they don't. We have not entered any customer for them, so they will be in don't have condition. So this is the result. So this inner query, so for each customers it will be get executed. So the first row in the salesman table is John. So for John, John's city is Bangalore, not in his customers city will be replaced over here. So his customers will be, so John's customer are from 1000, so Bangalore and Mangalore. So now the query would look like this: S2 dot city not in Bangalore comma Mangalore, but his city is Bangalore, so Bangalore is present inside. So this where class will evaluate to false. So John will not be present. Then similarly for Ravi, Ravi's city is Bangalore. Bangalore not in. His customers are from Chennai and Bangalore. So since Bangalore is present inside this, Chennai and Bangalore will be for Ravi because he has a customer from those two cities. Bangalore is present inside. So not in condition is present over here. So it again fails. So Ravi is also not selected here. Then for Kumar, Kumar's city is Mysore and his customer city is Bangalore. So Mysore not inside this particular list, only Bangalore is present. So Mysore is not present. So we have not condition. So Mysore not in Bangalore. So that will evaluate to true. So since that evaluate to true, Kumar is selected in this particular query and Kumar will have an indication don't have. So similarly, Smith and Harsha, they don't have any um, customers at all. So here it will be blank because they, since they don't have a customer, this will be empty. And anyway, since this is empty, not in condition will evaluate to true. And they will also have the indication don't have. So this is the third query. And the fourth one, create a view that finds the salesman who has the customer with highest order of the day. So what we have to do is for each day, we have to select its highest order. So here again, in order to solve this, for each day, we have to find what is the maximum order placed. So again, that will lead to a correlated nested query. So in order to find, but in the end result, we need the salesman information. So what we have to do is we have to join the salesman and orders table. And here a view has to be created. So the syntax will be create view, name of the view. So name of the view is highest salesman, as keyword, select ordered date, salesman ID and name. From which table? Salesman and orders table with alias S and O. And we will join these two tables using S dot salesman ID is equal to O dot salesman ID and O dot purchase amount is equal to. So purchase amount should be equal to maximum amount of that particular day. So for each row, we'll check is it the highest order of that particular day. So there will be a correlation. So what we'll do, select maximum of O2 dot purchase amount. So if you observe here O2, O2 is from orders table only. So orders table is playing the second role over here in the same query. So again O2 where O dot order date is equal to O2 dot ordered date. So this O is acting as a outer table and O2 is acting as a inner one. So since here in this query O is not present, so it is present in the outer, so it becomes a correlated nested query, and for each row in the outer query this particular inner query will be executed. So for each row its date will be taken and here it is applied, and maximum purchase amount for that date will be selected over here, and then the comparison will take place whether the amount of this particular row is the maximum amount of that particular day. If it is the maximum, that is equality is met, then that particular entry will be selected. So once we execute this entire command, it will create a view. Once a view is created, we have to check the values using select star from highest salesman. So this is the name of a view. So let us go back to orders table and verify the results. So in the order table, so 20th February, there are two orders from customer ID 10. One is from salesman 1000, another is from salesman 2000. So then the purchase amount, so if you observe 5000, another one is 450. So the maximum order is 5000 and 5000's salesman ID is 1000. And the name of the salesman with ID 1000 is John. So John should be returned. For which date? For 20th February. Then similarly the second date, here for this row also the query gets executes and compares, but it is 450. 450 is not equal to 5000, so this entry will not be there in the result. Then the third entry, 26th May. So 26th May is again present two times. So one is 1000, 3500. So 3500 is the maximum value. So this particular third row, order number 52, is not the maximum value and it is rejected. Then again this particular entry, 26th May. So for 26th May, once again it will compute the maximum. The maximum value for 26th May is 3500. So the 3500 is equal to the purchase amount of this particular tuple, and its salesman ID is taken. So salesman ID is 3000 and the salesman with 3000 ID is Kumar. So for 26th May, Kumar will be the salesman with highest order. And the next 4th August, only one entry is there. So it has to be the maximum of the day that itself. So that ID is salesman ID is 2000. So the salesman ID 2000 is Ravi. So for 4th August, Ravi is the salesman. So now when we execute this particular query, so you can observe here 20th February, John, 26th May, Kumar, and 4th August, it is Ravi. So this is the result. So you can run this and check the results. So 5th query, demonstrate the delete operation by removing a salesman with ID 1000. All his orders must be deleted. So delete, the query is delete from salesman where salesman ID is equal to 1000. So while creating the salesman table, we have put or in the orders table. In the orders table, while creation, for the salesman ID, we have put it as a foreign key and we have also specified on delete cascade. So since on delete cascade is specified in the orders table, if a salesman is deleted here, automatically all the orders in which the salesman ID is 1000 will be deleted. So we can observe after executing this deletion command, so we can observe the salesman table. So 1000 is not present. From customer, you can see that this particular salesman ID is set to null. So this dash indicates it is null. So in customer table, we had used the class on delete set null. Orders, you can observe the 1000 salesman ID is not present over here. So from order table also it is deleted. Okay, so these are the 5 queries in this particular second experiment. So I will share the manual. So create the tables, insert the values, and run these queries and verify the results. So you can enter your attendance in the chat and exit.